In this video, we continue with chapter 4.7 examples and take a look at some transition matrix calculations. So we have just seen that P is the transition matrix from B prime to B. And so when we're trying to find the scalars to get in the opposite direction from B to B prime, we use the inverse of that transition matrix. So now we are going to calculate, given these non-standard bases B, V1 through Vn, and B prime U1 through UN, and the standard basis S is E1 through En in Rn. So we are going to see that you can calculate the transition matrix from B to the standard vectors with V1, V2 through Vn just converted to column vectors and put together in a matrix, and that's because we're going to the standard basis. And if you're going to a non-standard basis, B prime, you use these U's here. Both B and B prime are square invertible matrices. B is a transition matrix from B to S, and B prime is a transition matrix from B prime to S. So to get the P inverse, the inverse of the transition matrix, and P inverse transitions us from B to B prime. That's the direction we're usually working in. Start with B, get to B prime. You first can think about applying B transitioning from B to the standard vectors. And then you could think about B prime inverse taking you from the standard vectors back to B prime. So what this is really saying is sometimes when we've got two non-standard bases, we use the standard bases as an intermediate step. So you can think about P inverse as B prime inverse multiplied by B. And so you can also, using inverse properties, going the opposite way, you can think about, well, P is just B inverse B prime. And then over on the right, I've got some alternate ways of writing this. So let's take a look at an example here. So in this example, we've got V1, V2, and V3 corresponding with our bases B, and these are non-standard. So V1 is 1, 0, 1, V2 is 1, 1, 0, and V3 is 0, 1, 1. And then our starting column matrix is 2, 3, 1, and that's in basis B. And then we want to find XS, which is the corresponding column matrix for the standard basis. So we're just going to the standard basis, the 1, 0, 0, 0, 1, 0, 0, 0, 1. So we know that P inverse of going from B to S is going to be what we think of as the matrix corresponding with B going from B to S. And so that's going to be taking B1, B2, and B3 and just placing them as column values in this matrix. And then to find X's in the standard basis, our X's sub S, we're going to do P inverse multiplied by our XB that's given to us in the standard basis. So this calculation is going to be 1, 0, 1, 1, 1, 1, 0, 1, 1 inverse multiplied by 2, 3, 1. And we can let SIMPy or other technology do that for us. And we find our values are 5, 4, and 3. So this is our X sub S, our coefficients for the standard basis, where remember S is this set of the standard basis for R3, 1, 0, 0, 0, 1, 0, and 0, 0, 1 here. All right. Let's do another example. So now we're given B prime equals U1, U2, U3. And this is another non-standard basis, 8, 11, 0 for U1, 7, 0, 10 for U2, and 1, 4, 6 for U3. And then X is 3, 19, and 2. And so now we want to find the x sub b prime, so the scalars corresponding with transitioning to b prime. So still working with our same values. So we're going to set up matrix b prime. So matrix B prime is going to be the column vectors associated with U1, U2, U3. So it's going to be 8, 11, and 0, 7, 0, and 10, reading column wise, and 1, 4, and 6. And then our transition matrix is going to be this. So then we're going to do P inverse. So what we think about is P inverse is just P prime inverse is just the inverse of this matrix. So I'm going to just write it as inverse, and then we'll rely on technology to do these calculations for us. And so now to find x in the scalars transitioning to the new basis B prime, our calculation is going to be P inverse times x sub s, our values in the standard basis. So then we have our 8, 11, 0, 7, 0, 10, 1, 4, and 6 here, inverse multiplied by our 3, 19, and 2 here. And so then you can go check on SIMPy, and those values work out to be 1, negative 1, and 2. And you're also welcome to use a graphing calculator or whatever matrix multiplication tool you like. I like SIMPy because it's free and online, but any tool you have is fine to find the inverse and multiply these matrices. Okay, so we see our calculations here to change basis are essentially finding the matrix that's going to be our transition matrix, inverting it, and then multiplying it by our given vector x as a column vector. So here's another example. Now we're going to go from B to B prime. So they're both non-standard bases here. So B is V1, V2, V3 here. And B prime is U1, U2, U3 here. So none of them are standard bases. And then our x B prime is 1, 2, and negative 1. So we want to find the transition matrix and then use it to find xb in the original basis B. So now we're going in the opposite direction. So instead of using P inverse, we're going to use P. So let's set up our matrices here. So B is 1, 0, 2, transitioning to column vectors, 0, 1, and 3, and 1, 1, 1. And then B prime here is the column vectors associated with U1, U2, and U3. So 2, 1, 1, 1, 0, 0, and 0, 2, 1. So now neither of our bases are the standard bases. So we are going to use that formula that P equals B inverse B prime. So our calculations here are going to be 1, 0, 2, 0, 1, 3, 1, 1, 1, inverse, multiplied by 2, 1, 1, 1, 0, 0, and 0, 2, 1 here. And so when we multiply that out, we get 1/2, negative 1/2. You can double check in your matrix calculator, SIMPy or whatever tool you're using, 3/2 here. Sorry, my handwriting's not so great. I'm going to go over here. I think I got a blank screen and write it a little bit bigger. So this is 1/2, negative 1/2, and 3/2 in the first column. So these came from multiplying B inverse and B. Then we have 1/2, -1/2, and 1/2. And then in our third column, we have -5/4, 3/4, and 5/4. Okay, so this is our matrix P. If you wanted to go in the other direction, you would find P inverse just by doing B prime inverse. So if you want P inverse, that formula is B prime inverse times B. But in our case, we are going from B prime back to B and finding X in the original basis B. So we're just going to use the matrix P. So our calculations are going to be X in the original matrix B, where X is that column vector, is going to be P times X and B prime, because we're going what I think of as a forward direction. We're using the transition matrix P, not its inverse. So these are going to be, I'm going to try my best to recopy matrix P here, 1/2, -1/2, and 3/2, and then 1/2, -1/2, 1/2, and -5/4, 3/4, and 5/4, multiplied by our X sub B. So that is, as a column vector, 1 to 1, 1 to -1, where that's just coming from what was given to us right here in the original problem. And so when we multiply through, we get our X in the original basis is 11/4, -9/4, and 5/4. And so you can verify my multiplication using simply or any other matrix multiplication tool. Here's some more examples of transition matrices. So we are going to look at these in the next video.